Okay, Houston, we've had a problem here.
This is Houston. Say again, please.
Houston, we've had a problem.
Houston, we don't have any problems. Today we are going to enter a new unit about Newton's laws. Sir Isaac Newton, right? A little history to start off with. You know that Aristotle, who was a Greek philosopher, right? He had some common sense ideas about how to explain physics. He said that objects in motion maintain their motions without, he noticed this, right? That without assistance. He called these natural motion. Examples of these would be like rocks falling off ledges, liquids going downhill, air rising, flames going upward. You can see the different things here in the notes. But then there were motions that were unnatural, and he calls these violent motions. That's when it has to be pulled. It doesn't happen naturally. If you want to like pull something up a hill, you have to do something, and those are called violent. Not violent. Aristotelian physics had a hard time explaining, though, many things. But actually, many people still kind of view Aristotelian physics without knowing that it's been debunked. So here is sort of the big question. What if I have two pieces of paper, one that's crumpled up and one that's flat? What Aristotle noticed is this fell fast and this fell slowly. Okay? So that actually obeyed Aristotelian physics. But what happens, though, if we take two objects with the same shape but very different masses? So if I have a sphere here that's heavy and a sphere here that's light, and we drop them, the crazy thing is, and we've seen this in class, they land at the same time. So what Aristotle had said is that how fast something falls depends on its weight or its mass. And what this experiment shows, excuse me, that it doesn't always work. So that's an interesting thing that was discovered. So this leads us to Galileo, who found that to be true. He had an interesting thing called his law of falling, okay? So let's see. So that leads us to what Galileo said was the law of falling. Now, this is Galileo, who did this crazy important experiment where he dropped things off, the Leaning Tower of Pisa, the whole ball game, and he said this. He says, if air resistance is negligible, then any two objects dropped together will fall together, regardless of their masses, shapes, or materials. Anything. Now, what I'd like you to do is actually draw some pictures. So a duck, a velociraptor, a book, an atom, anything. So I want you to, in the notes, draw what that might look like to help you remember this. This is really cool. A cool fact is that the falling of an individual atom. So a couple of interesting facts, right? Astronauts confirmed this on the moon when they dropped a feather and a hammer, all right? Another cool fact is that they did an individual atom was tested in 1999, and it meant they had to do this to neglect the air resistance. They had to cool it to like 2/millionths of a degree of absolute zero, but it also worked. And some other notes here about Galileo, because he's awesome, because he's really super awesome. All right? Take a moment to read this. Which leads us to really how things move. When we talk about how things move, there's a kind of a really like crazy important thing we need to learn about, and that's this concept of inertia. Inertia is a very, very important topic. What's inertia? An object's tendency to keep moving or to remain at rest, if you will, to maintain its motion. So some objects, well, all objects really, they keep moving or they keep staying at rest? Well, dependent. Which leads us to the law, right? Newton's first law. As a side note, this law was not actually developed by Isaac Newton. It was actually developed by René Descartes, but Newton gets credit. Interesting. So what's Newton's first law, the topic of this video? An object that is subject to no external forces will remain stationary if it's already stationary, or it'll keep moving if it's moving with a constant velocity. That is Newton's first law. Now let's kind of tease this out a little bit. So consider an object in space, far from the gravitational forces of objects in space. If the object was stationary to begin with, then it will remain at rest until an external force is applied or acts upon it. Similarly, if an object is moving with a constant velocity, then it will keep moving or stay at constant, need more space here, velocity until an external force acts upon it. So what does that look like? So let's think about this. If I have a stationary object, right, where the velocity, right, is equal to 0 meters per second, what will it do? It'll stay not moving. Similarly, if I have another object and it's moving at, say, 10 meters per second, right, so V equals 10 meters per second, it continues at 10 meters per second, or whatever, or at, whatever the velocity is. So let's do an example here. We're going to use Newton's first law to explain why it's important for you to wear your seatbelt in a moving vehicle. All right, so you're driving down the road in your car, right? So an object at rest stays at rest at a motion. So you are in the car, and so you have a particular velocity. But of course, the point of a seatbelt is to prevent you an accident. So what happens when the car hits something, a brick wall? Hopefully this will never happen to any of us, right? You hit a brick wall, another force is going to act upon it. That's the force from the brick wall. And what's going to happen, the car is going to suddenly stop when it hits the brick wall. But you, right, you in this car, if you have no seatbelts, you're going to continue to move at velocity, and you will continue to move and then maybe potentially hit the wall or whatever it might be. So let's think this through. Let's just say this. The car stops, but you keep moving. And then maybe you'll fly out of the car through the windshield or something like that, and then that could lead to disastrous consequences. So that's Newton's first law in a nutshell. Not much math or anything like that. It's understanding that an object at rest stays at rest. An object that is moving will continue to move. Later we're going to talk how do we actually change the path of movement by these external forces that we just talked about. But that's all we need to know for Newton's first laws. We'll see you guys in class.
Okay, Houston, we've had a problem here.
This is Houston. Say again, please.
Houston, we've had a problem.